Hello friends, welcome all of you once again. Today we see 12th Science Physics Center of Mass point with important tips and MHT CET objectives with proper solution. So let's start today's video. First we see some important points of the center of mass. The first important tips or important point is center of mass of a body is the average position of its mass, that means rather than its weight. Let's see the next point. A body's center of mass is exactly in the same position as its center of gravity, provided the gravitational field strength does not vary within the body itself. Next point, it is in the absence of external force, the center of mass of a system moves with uniform velocity. Center of mass of a system may or may not lie inside the system. So let's see the other important points of the center of mass. The position of center of mass is independent of the choice of the coordinate system. The position of center of mass remains unchanged in rotatory motion, while the position of center of mass changes in translatory motion. And the next point, it is the sum of moments of masses of the system about the center of mass, it is the 0. So these are the various important points of the center of mass point. So let's see the objectives. First objective is a cricket bat is cut at the location of its center of mass as shown in the figure. Let's see the first figure, it is regular bat, and it is the second one, bat cut at the bottom point. The options are, option A is two pieces will have the same mass. Option B is bottom piece will have larger mass. Option C is handle piece will have larger mass. And option D is mass of the handle piece is double the mass of the bottom piece. So let's see the solution. As we know that center of mass is closer to the massive part of the body, therefore the bottom piece of the bat has larger mass. So here option B is correct, that means bottom piece will have the larger mass. So let's see the second objective. Two particles of masses m1 and m2 initially at rest start moving towards each other under their mutual force of attraction. The speed of center of mass at any time small t when they are at a distance small r apart is. Let's see the options. Option A it is the 0. Option B it is the g into m1 m2 by r square into the 1 by m1 into the small t. Option C is g into m1 m2 by r square into 1 by m2 into the small t. And option D is g into m1 m2 by r square into the 1 divided by m1 plus m2 into the small t. So let's see the solution. As initially both the particles were at rest, therefore the velocity of center of mass was 0 and there is no external force on the system. So speed of the center of mass remains constant. That means it should be equal to 0. So here option A is correct. Let's see the next objective. A thin uniform rod of length small l and mass small m is swinging freely about a horizontal axis passing through its ends. Its maximum angular speed is omega. Its center of mass rises to a maximum height of. Let's see the option. Option A is 1 by 3 L square omega square into the small g. Option B is 1 by 6 L omega divided by small g. Option C is 1/2 L square omega square divided by small g. And option D is 1 by 6 L square omega square divided by the small g. Let's see the solution. See the figure, A it is the initial position, B it is the next position, or we can say it as the final position. As we know that rotational kinetic energy at position A, which has having the formula 1/2 I into the omega square. And potential energy at B position, which is equals to the mg into the small h. By using the law of conservation of energy, we equating these two equations, we get mgh is equals to 1/2 I into the omega square. Putting the value of the moment of inertia in this formula, we get the new formula mgh is equals to 1/2 into the bracket ml square divided by 3 into the omega square. Simplifying this equation, we get final answer, it is the h equals to L square omega square divided by the 6g. So here option D is correct. Let's see the next objective. Identify the correct statement for the rotational motion of a rigid body. Option A is individual particles of the body do not undergo accelerated motion. Option B is center of mass of the body remains unchanged. Option C is center of mass of the body moves freely in a circular path. And option D is individual particles and center of mass of the body undergo an accelerated motion. So as per our theory knowledge, the answer it is the option B, that means center of mass of the body remains unchanged. So let's see the next objective. Two persons of masses 55 kg and 65 kg respectively are at the opposite ends of a boat. The length of the boat is 3 meters and weighs 100 kg. The 55 kg man walks up to the 65 kg man and sits with him. If the boat is in still water, the center of mass of the system shifts by. Option A is 3 meters, option B is 2.3 meters, option C is 0, and option D is 0.75 meters. So let's see the solution. As per our theory knowledge, there is no external force, so center of mass will not shift. Here the option C is correct. Without calculation, we have get the direct answer, that means 0. Option C is correct. Let's see the next objective. Number 1 is the center of gravity of a body is the point at which the weight of the body acts. Number 2, center of mass coincides with the center of gravity if the earth is assumed to have infinitely large radius. Number 3 is to evaluate the gravitational field intensity due to any body and at an external point, the entire mass of the body can be considered to be concentrated at its center of gravity. And 4 number, it is the sentence. Radius of gyration of any body rotating about an axis is the length of the perpendicular dropped from the center of gravity of the body to the axis. The question it is the which of the following pairs of statements is correct? Option A, it is the 4 and 1. Option B, it is the 1 and 2. Option C, it is the 2 and 3. And option D, it is the 3 and 4. So we know that as per our theory knowledge, option A is the correct. That means number 4 and number 1. That means number 4, it is the radius of gyration of any body rotating about an axis is the length perpendicular dropped from the center of gravity of the body to the x, it is the correct statement. And number 1, it is the center of gravity of a body is the point at which the weight of the body acts. So here friends, we see some important points and the MHT CET objective in of the point center of mass. So today we stop here. In the next video we see some other important points and objectives.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.